In this video, I'll be talking about rates of reaction from C2 AQA chemistry. Alright, so to get going, the rate of reaction can be found by measuring either the amount of the reactant that's actually used up or the amount of a product that's actually formed. So remember, reactants go into a reaction and products come out. And if you're figuring out the rate, you've always got to divide it by time. So this is not an equation that's actually given to you, it's a concept, it's an idea. So you always got to divide the amount of a reactant that's used up divided by time, or the amount of a product that's formed over time. So there's some reactions that happen very, very quickly, say like a firework going off, some reactions that happen very, very slowly. Chemical reactions can occur when reacting particles collide with each other with sufficient energy. So that last bit over there is the key point. That bit where it says sufficient energy, that's the point that most people forget. Yeah, they can collide, but they might not actually have enough energy for them to actually for them to actually start the chemical reaction. Okay, this minimum amount of energy that particles actually have is called the activation energy. That's what we call that minimum amount of energy that they actually need to start the reaction. So we've got some factors here that affect the rate of reaction. If you increase the temperature, it increases the speed of the reacting particles. Okay, so they collide more frequently, more energetically, so it increases the rate of reaction. I want to point out there the process. When you're talking about increasing a factor, i.e. temperature, that affects the speed and the fact that it actually makes them collide more frequently and more energetically. So you've got to talk about the frequency of collisions and the energy of collisions. If you increase the pressure, it increases the frequency of the collisions, so that increases the rate of reaction. If you increase the concentration, so let me highlight pressure there as well. If you increase the concentration of the reactants, in other words, what goes in, the frequency of the collisions increases, so therefore the rate of reaction increases as well. An increase in the surface area of the reactants increases the frequency of the collisions as well. We can use catalysts, and catalysts actually change the rate of a chemical reaction, but they're not used up. That's the key fact there. They're actually not used up during a reaction. Different catalysts need, different reactions need different catalysts. So different catalysts actually work in different reactions. Okay, they're important in increasing the rate of chemical reactions used in industry and reducing costs, because they don't need to be paid for once. If they don't get used up, you only pay for them once. So they can speed up a reaction. They don't get used up, so you're only paying for them once, but you're getting your yield quicker. You're getting your output quicker. So when these chemical reactions actually take place, they release energy. Some of these reactions give out energy and some of them take in energy. So we need to talk about each of those in detail. But remember, this energy is always transferred to the surroundings. Okay, so chemical reactions transfer energy to or from the surroundings. So either giving energy to the surroundings or taking energy from the surroundings. If it's exothermic, okay, it transfers energy to the surroundings. Okay, so like combustion, oxidation, neutralization, and there's simple versions of these that they ask about quite often in exams. Things that we see in the real world, like hand warmers or self-warming cans of coffee. An endothermic reaction is one that takes energy in from the surroundings. So if it's endothermic, it takes energy in from the surroundings. Okay, so thermal decomposition is an endothermic reaction. Okay. So these sport injury packs, okay, that ends up so like cold packs where you just break them and all of a sudden they're very, very cold. Okay, they're endothermic reactions too. So reversible reactions, which we discussed in the last video, if they're exothermic in one direction, they're endothermic in the other. So you can see that over here, it's endothermic this way, so it's going to be exothermic this way. Okay, in each time you go each way, if a certain amount of energy is released this way, the same amount of energy is released on the way back. Okay, and that's our video on rates of reaction and energy in these chemical reactions.